Good morning and welcome to Algebra 1 for Wednesday, May 13th. Today we're going to talk about the third and final form of a quadratic equation, which we call standard form. As you can see behind me, standard form is y equals ax squared plus bx plus c. It's just another way to look at the equation. The a, the b, and the c will all be numbers in an actual equation. This is just the template, the basic form, without the actual values to form the graph. There will always be an x squared term in standard form. Sometimes the b or the c could be the number 0, which would mean that they wouldn't appear at all. So if b were 0, there'd be no x term. It would just be something x squared plus or minus something. There could even be a 0c value. So it could just be y equals x squared. A can never be 0 because a has to be at least, it has to be anything that's not 0. It could be 1, it could be an integer above 1, it could be lower than 1, it could be a fraction. Can't be 0 though, because if it were 0, there's no x squared term, so it wouldn't curve. So that's the only issue, the only limitation here is in A. So A, B, and C will be numbers. There will be an x squared term. I'll obviously give you an example so that we can see what to do and how to graph it in standard form. So here's an example, okay? Y equals 2x squared plus 16x plus 24. Okay. I want you to understand that the first thing we ought to do, certainly now because we're just starting it, but even later when you're comfortable with what you're doing, is you should identify your A, B, and C values. So I'm just going to write down what A and B and C are because it helps keep things straight. A is the coefficient of x squared. It's whatever number is right over here. If it were negative, we'd have a negative number, but if not, it's a positive number. It's the number 2. Our b term is a positive 16. I don't have to write the plus sign to indicate it's positive, but that sign does follow the b term, so it's 16. If it said minus 16x, it would have been a negative 16. Same thing for the c term. It's positive 24. I'll just write 24. It's handy to write down and identify what a, b, and c are, especially when there's a missing term, because that would be a 0. How do we graph it? Well, just like the previous forms with vertex form and with intercept form, we have to find the vertex. Here's the process for finding the vertex when your equation is in standard form. First, we have to find the x value of the vertex. So, the x value of the vertex is equal to negative b divided by 2a. Write that down. Take some notes. This is very important information. This is how you're going to find the vertex. I already identified A, B, and C, which will come in handy right now. The x value of my vertex is negative b. Well, that's negative 16. Divided by 2 times A. A I identified was 2. So it's negative 16 divided by 4, which is negative 4. So my vertex, I've identified the x value is negative 4. I just don't know yet what the y value is, which, of course, I'm about to find out by plugging in negative 4 for x. So y equals, I'm just using this equation, but I'm replacing the x with the number negative 4. So 2 times negative 4 squared plus 16 times negative 4 plus 24. Please, please, please remember the order of operations. PEMDAS. Parentheses, if there's any work to do, comes first. I do have parentheses, but there's no work to do inside of them. They're just the number negative 4. Don't worry about that. Exponent comes next. We have to use the exponent. So it's not 2 times negative 4. It's not. It's negative 4 squared first. What's negative 4 squared? And really be careful if you're using a calculator, because if you say negative 4 squared, it's going to tell you negative 16, but that's wrong. Negative 4 times negative 4 is positive. If you don't use parentheses around the negative 4, you won't get the right answer from the calculator, so be careful. Negative 4 squared is 16. Plus, well, what is 16 times negative 4? I could certainly do that here. 16 times 2 is 32, so twice that. Negative 64 plus 24. Okay, so 2 times 16 is 32 minus 64 plus 24. You can feel free to use a calculator if you'd like, but 32 minus 64 is negative 32, plus 24 gives you 8. So I found my vertex. It's at negative 4, 8. This form is not as easy as using vertex form or intercept form. There's more work to do. Unfortunately, you'll often get equations in standard form. So we do have to know how to do this. All right, I identified my vertex. Now, what do you think I should do? Well, just like every other time, we can and probably should use a table of values to graph the equation. So I'm going to make my t-table with the vertex planted in the middle. I'm going to move 2 away to either side of x. And we have to plug them in to find out the output. Again, we don't have to do all 4. You could just do the first 2, and if you do everything correctly, it will reflect on the other side symmetrically. If you're not confident, do them. Use a calculator with parentheses. It's not that hard to do. So I'm just going to show you the negative 6. So it's 2 times negative 6 squared plus 16 times negative 6 plus 24. If you just plug that into your calculator as it appears, it's going to give you the answer in one step. It's fine. You don't have to do every single step on paper. But if you did, it's 2 times 36. Positive 16 times negative 6 is negative 96 plus 24. So 2 times 36 is 72 minus 96 plus 24. If you just do that out, you find out you get, anyone? 0. Okay, so negative 6 gets me a 0. Do the same thing for negative 5. And if you want for negative 3, and if you want for negative 2, the value should be, and I think I forgot a negative sign. Oops. Wasn't that negative 8? I can't go backwards in my my whiteboard. But I believe that was supposed to have been a negative 8. Yep. That was my error. I realize that now. Nothing's wrong with this. It's still a 0. But that was supposed to have been a negative 8. If you got a negative 8 and you were questioning yourself, well, pat yourself on the back. You were right. Okay, so in any case, if I plug in a negative 5, we can do the math out, but I have run out of steam to do all of them. I'll show you one more. Got to redeem myself. So 2 times negative 5 squared plus 16 times negative 5 plus 24 is 2 times positive 25. Positive 16 times negative 5 is negative 80 plus 24. That's 50 minus 80 plus 24. 50 minus 80 is negative 30. Plus 24 is negative 6. I'm going to have confidence that it will reflect symmetrically on the other side. That's my t-table. I would just graph it accordingly. Again, we graph the same way we always are graphing. Get out either a carefully measured piece of paper, or if you happen to have pre-printed coordinate grids, that works. I have to go to negative 6 on x. I have to go to negative 8 on y. I don't have to worry so much about the positives, but if you want to have the lines just because it's nice to see them, go right ahead. Negative 6, 0 is right here. Negative 5, negative 6. So it comes down to about over here. I'm trying to eyeball it. Negative 4, negative 8. It's all the way down here. Negative 3, negative 6. Negative 2, 0. Okay, so it comes down, turns around, goes back up. Remember the same language we've been using all along. The place where the curve turns is called the vertex. Because this parabola opens up, the vertex is a minimum. We see how it's decreasing as it gets to the vertex, and then it's increasing as it moves away from the vertex. Okay, so there is our one example I wanted to show you. There could be all sorts of different examples and different ways to look at it. But the process is going to be the same each time. Let's say we'll do a simple, sort of simple one here. I'll give you a fractional one, and I'll do it for you. This is not going to be your homework. Your homework prompt is coming in a minute. So let's take a look at this and see what we get. So again, the process, identify your A, B, and C. So my A is a half. My B is the number 6. My C is 16. We then want to find the x value of the vertex. So we're going to write x equals negative b over 2a, and then plug in the right numbers. It's negative 6 over 2 times a half. That's negative 6 over 1, which is negative 6. So we found the x value. Then we plug it in to find y. It's 1/2 of negative 6 squared plus 6 times negative 6 plus 16. Order of operations, it's 1/2 of 36 minus 36 plus 16. Half of 36 is 18 minus 36 plus 16. 18 minus 36 is negative 18 plus 16 is negative 2. And again, use a calculator. You don't have to show everything on paper. So my vertex is negative 6, negative 2. And then we will do what we always do, which is we make a t-table. Negative 6, negative 2 is right there in the center. So I'm going to go negative 7, negative 8, and negative 5, negative 4. So far, so good. Okay, so let's just take a value, plug it in, see what you get. So if I plug in the negative 8 squared plus 6 times negative 8 plus 16, it's half of 64 minus 48 plus 16, which is 32 minus 48 plus 16. 32 minus 48 is negative 16. So if I add 16, that gets me a 0. So this is also going to be a 0 because I know that it's going to be symmetric. Plugging in the negative 7, y equals 1/2 negative 7 squared plus 6 times negative 7 plus 16. That's 1/2 of 49 minus 42 plus 16. Yes, you can have decimals or fractions. It's not that big a deal. Half of 49 is 24.5 minus 42 plus 16. 24.5 minus 42 is negative 17.5. Right? And if I add 16 to that, I get negative 1.5, right? Hopefully. Yep, I don't have a calculator. Oh, I do have a calculator. What am I doing? I'm looking at a calculator right here. So 24.5 minus 42, negative 17.5 plus 16 is negative 1.5. Never hurts to double check. So negative 1.5. and it's going to be symmetric. And again, don't be afraid of decimals and fractions. They can exist. It's not a problem. And then we can graph that. This time I need a lot of negative x and not much in the way of negative y, but a little bit. So I'll go like that. 1, 2, 3, 4, 5, 6, 7, 8. Didn't really space those that well, which is another good reason to have graph paper handy. So negative 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, right over there. Negative 7, negative 1.5, so halfway between the negative 1, negative 2. Negative 6, negative 2. Negative 5, negative 1.5. Negative 4, 0. So we have our parabola. Arrowheads on both ends. Not too big a deal. If you happen to have a graphing calculator, you could certainly use it. If you want to use Desmos, you can use it. It's okay. So if I want to use a graphing calculator, I'm just going to type in 0.5x squared. It's easier than using fractions. Plus 6x plus 16. So you have it entered there, and if you want to see what it looks like, you would just graph it. Make sure you have a good window. This one looks like Zoom standard. Should be fine. Zoom 6. Okay. I also realize I have a box and whisker plot I want to just not graph. Okay. So turn that off and show you again. So it graphs it. Looks fine. Not a problem there. If you wanted to see the table, you certainly can just click the second graph button and it'll show you the values and you can move up and down. But the values are right there. So our answers were correct and we should be pretty content in seeing that. All right, well, all that remains is to give you a simple single prompt for your homework assignment, all right? So all I need to see is how you find the vertex and how you graph the equation. There is only going to be one for homework. Here it is. Your homework prompt is the equation y equals x squared plus 4x minus 5. What do you have to do? Find vertex. Make the t-table and graph this one equation. I do want to see the math behind you finding the vertex and making the t-table for at least one of those calculations. I understand you can use Desmos or a graphing calculator. I want to see some math on paper also. So please do. It's just one prompt. Send it to me by tomorrow morning at 10 a.m. and I'll give you full credit. Have a wonderful day.